Translators and IDEs. There are two types of programming languages, high and low. High, think of high in humans, both start with a H. They're ones that, when you look at them, kind of make sense. They read a little bit like English. Low is in machine code, in binary. Okay. So high-level languages are things like Python, C++, and JavaScript. One instruction, so if I type print into Python, then that signifies many machine code instructions. There's lots of different bits of binary have got to happen to do that one little bit of instruction. The same code is machine or CPU independent. So if I make a Python program on my computer, I run it on a Mac, as long as it supports Python, it'll run. Okay? So the idea is once you've got that piece of code, it'll work on any other computer. Code's easy to read, and it kind of makes sense. So the way we do it is while equals true, so while it's true, or print, quote, hello, we're expecting that string to be printed. It's easy to read, it makes sense to humans. The problem with it is, though, is it must be translated into machine code to run, because a computer can only see zeros or ones. So when you type all this Python code up, every single line has got to be converted into machine code. And this makes it less memory efficient and slower, because you've got no control over the CPU. Instead of you going to get something, it's like asking your friend to go and get it from the shops for you. Well, you've got no control over how long that's going to take them to go, how they're going to get it, what time they're going to get back. It slows the whole process down, opposed to you going and get it yourself. Low level is machine code, or zeros and ones. And there's another thing called an assembly language, where words like add are little instructions that perform instructions on machine code. Okay. It's written for one machine or a processor. So a certain processor, let's say an Intel dual-core processor, 3.4 gigahertz, that specific processor code is written for that machine. The commands are executed directly. So when I type a command in a low-level machine code, it's like I'm talking directly to the CPU. So because I've got control over the CPU, I've got more control of what happens. So that's more memory efficient and faster. I haven't got to go through a middleman. I'm cutting the middleman out. So for most people, high-level programming languages are appropriate. We don't talk in machine language. But if you want to be more memory efficient, you want to work directly with the CPU, then you've got to learn a low-level language, okay, or a machine code. So we've got this problem of converting to machine code. We as humans, we're going to write in Python. It's easy for us to understand. It's using syntax, it's words we understand. So how are we going to get it into machine code? Because the computer only understands zeros and ones. The higher level language needs to be translated. And the two main ways of doing that are compilers or interpreters. Now these are the differences they might try and trick you out on in the exam. A compiler translates all the source code and creates one file. So it opens up the file, it goes through the whole thing, and it makes one executable file. It returns any errors after it's been compiled. And it takes its time, but the program will run faster. So that's like proofreading a book. You read the whole book, and at the end, you then say, well, on page 23, there was this bit, I didn't like this, blah, blah, blah. But it takes a long time to get through it, but it's faster. An interpreter is different. An interpreter runs line by line, and it's needed every time that program is run. So every time the program's run, you need the interpreter. Now the problem with this is, as soon as it gets to an error, it stops. So as soon as you've got a syntax error, it will just stop. It runs more slowly because it's being translated while it's running. It's doing it on the fly. It's kind of like somebody writing a book and they're only writing a page ahead of what you're reading. Okay, that's slower. Integrated Development Environments, or IDEs. Basically, this is software to help with help features for developers. If you just wrote everything in Notepad on a black and white screen, that's very, very hard to understand. So, certain software is developed to help us out. So we might have a code editor, which is color coded. So keywords like import or from, they're a different color. If you define a function, that's a different color. If you use a Boolean statement like true or false, they might be red. The output window, so you can see what happens without having to save it and run it. I know we used idle for the coursework, but probably Visual Studio would have been better because you see what's happening in an output window. Any errors come up in an error diagnostics, so it will say, right, line 22, this error. And you've got an Explorer window, so you can see the file. So if our code, let's say, had a feature where we exported and we created a CSV file from the code being run, well, if you've got an Explorer window, you can see those files being made. And generally, it's designed to give you as much help in making the code as possible.